Hey, Foundation Technology, this is another production from your favorite teacher, Mr. Goody. This one is about telecommunications, which is communicating over a long distance. Think about it, we've always communicated from back way. And the cool thing about it, it's come a long way from even the past 20 years. We've came from just talking on landline phones. Then now we're on wireless phones, and it's basically everywhere we are. But we started where we just communicating face to face, and over time we just wanted to get farther away and figure a way out to communicate. You've heard of the Pony Express. We've used to deliver messages on horses. We used to send mail, which some of you guys don't do that anymore. Went to phones, and now it's email, and it's but there's all kinds of different ways to communicate messages over long distance. And with that, we have telecommunications. Now, to understand a little bit about it, you got to understand some of the basic electrical principles. We have two types of current: AC/DC. It is not the band. That's kind of where they got the name from it, but AC/DC, alternate current, and direct current. Electricity is produced from electrons moving. Okay, or we got electrons going from one atom to the other. When that happens, we do have this thing called electricity. That is the basics behind movement of sound. We have goes through electrical wires. Now we're even going and making it digital and going through Wi-Fi. So there's different methods of making these electrical currents move. Now, just to give you an understanding of it, we got electromagnetic waves. They are similar to what we've already went over about the light wave. The light wave consisted of a wavelength, the amplitude, and direction that we focus on. This one, we're going to focus, instead of the direction that's going, is the frequency of the wave. Okay, the frequency is measured in hertz, and you guys heard the term hertz, kilohertz, megahertz, maybe gigahertz. But you've heard the hertz, kilohertz, megahertz, and you mainly hear that. Think about your radio stations, 96.9. That's a measure of frequency. Then you have in computers, you've heard these terms. That's how the speed of how things are moving. But again, it's all frequency is how many times a wave goes per second. Okay, and that's how that is measured. And we use electromagnetic waves to send our messages over the long distance. Now, types of signals, again, we've used analog in the past, and we still kind of do, but they're being replaced by digital, which hopefully you remember digital is zeros and ones. And the best way to think of analog is those magnetic waves, so it's the up and down motion of a wavelength. And then again, we are replacing them by digital, which is the 0 and 1 content. Kind of go in a little bit of history. Analog signals, just kind of rack your brain full of good info. That Thomas Edison was the first person to record these waves on a photograph. A phonograph was a little cylinder made out of like a waxy material that captured the waves, the voice waves, the sound waves coming onto it with a little scriber. And when it went around afterwards, they'd put it on the little player, and then it captured the sound and replayed the voice. And that was the first time this has been done in 1877. So we're a little over 100 years on capturing sound, and you kind of see where we've gone the past 10 years just with the digital world, with the MP3s and capturing our music and video and our movies. All those things came from the phonograph. But again, I'm going to kind of explain a little about AM and FM because it's easier to be seen when we draw it. But AM and FM, AM, we amplify the strength, and that's it. Which the amplitude, if you remember, is the height of the wave, so that's the strength of the wave. The FM is the frequency. How packed tight are they in 1 second? How many times do they go up and down per second? So we vary those to be able to reach those signals. Okay. The downside to analog, it's for example, if you are in your car, the easiest way to remember is the radio. If you're in a car and you go under a bridge, or if you go through a tunnel, they're interrupted fairly easy. The more stuff in between the wave and you, the harder the signal is to get you. If you guys think about the technology lab here at school, I can literally only get one station to come through all the brick, the concrete, the wood, and that's the one here in town. It's really hard to get anything else. And even sometimes when it's cloudy outside, I can't even get the one in here in town. So interruptions is kind of the reason we started to switch to digital. Here's the AM-FM comparison. Again, the AM, we keep the frequency the same, but we change the amplitude. That's how we can tune into the AM stations. We're just changing the amplitude, which is the height. Frequency, if you notice, the amplitude stays the same. The strength doesn't get any bigger, stronger. It just we change the frequency, which is how many wavelengths per second we get. Okay. Then digital. Hopefully, you guys remember it's made up of zeros and ones and less interference. I'm going to go ahead and kind of explain this backslide real quick. Okay, if we do this, we're going to draw this here. Yep. I'll get it here in a second. Just be patient with me. All right, so if we take this, we have the Earth. Okay, then we have our tower. High-tech tower. Then we have a little bitty car. Like so. That more looks like a tank, but that was the antenna, but it kind of went crooked on me. Anyways, on a AM or FM, we have what we call a direct current. So direct current, which is the FM stations. That means the farther you drive away, it has to come down and hit you directly. If for some reason you take and move, again, around the globe, we have the Earth's curve. And I know that wavelength will still reach it, but we're going to say, okay, now it can't get us. It hits the surface. We lose that station fairly quickly. Now think of the FM stations you guys put on 92.5 all the time. You drive towards Kansas City. About Fort Scott, you lose it. The signals have to directly go to you. They don't bounce off anything. They directly go to your antenna. That's the direct wave. Okay, so FM is that way. Now, if you've ever done AM, I'm going to kind of switch it up a little bit. And sometimes AM is really good, sometimes it's not. AM does this. Bounces off the layers of the atmosphere. Okay, so AM is what we call reflective waves. Now, if you've ever been in Kansas City and you've listened to 860 AM, that's out of Pittsburgh. And you can get to Kansas City and listen to some AM stations from Pittsburgh. The 860 AM that plays the Chiefs games, the Royals games, the Pitt State games, and you can find them over time. The only downside is when we have little clouds and thunderstorms striking down, we lose the signal. So it can be really good, therefore it also can be really bad because, again, the clarity of it's going to depend on what's in the atmosphere. Even if you're driving downtown and you have those big wires down, electrical wires, they're going to take some of that signal and you'll hear that fuzz. So that's kind of an explanation between AM and FM. It's kind of a neat system, but AM was discovered first before we changed it to figured out how to do FM. Okay, we talked about digital. Okay, and this is just a similar scenario. I kind of explained most of it. We broadcast through our antenna, then we receive it through our antenna, then we hear it through our speaker. Not a big deal on that one. Again, AM, FM. AM is the amplitude modulation, which changes the amplitude, and then later we found the FM, which again changes the frequency, how close the waves are together, and spread them out. So those are the two for radio broadcasting. Okay. Communication. Again, we talk about 3 special steps. Special Agent Oso had 3 special steps. Design the message. Again, just like in photography, you design it, then you go out and shoot it, or this time produce the message, and then lastly we broadcast it. Okay, so we design a message. Where are we going to produce, or we're going to produce it, but what for? Is it going to be television? Is it going to be radio? Is it going to be podcasted? There's whatever way we're going to do this, we need to decide that in designing the message, then producing the message, and then in the end, how are we going to broadcast it? Okay, so when we design the message, we want to know who we are designing it for. If we're creating a video for 30-year-olds to 50-year-olds, you're going to use the language for them. If you're developing it for first graders, you kind of need to change the language in your video to go back towards that type of language. Then select the approach. Audio, video, again, email is going to be podcasted. Find out what approach is going to be best. Then we go through and develop the message. Okay, I'm going to pause here and I'll come back to it a little bit later, so be patient.